module. I just want to get a quick summary of the last the concept that we just talked about. So basically, we had a journey on process automation from from microcontrollers, and so right now we have PLCs and DCS, programmable logic controller, and the distributed control system as the industry standard. So they have basically replaced microcontrollers, right?
They have not replaced. In fact, it is an evolution of the microcontrollers itself. If you look at the PLC, the inside out, you will find that it is an evolution of the same controller. The controllers have become very, very complex now. They are now having millions and millions of transistors and all. Earlier, they used to have discrete transistors and those devices which were combined and integrated into ICs, as we call them, integrated circuits. So basically, that was the integration of those discrete transistors and all into integrated circuits. And slowly, over a period of time, those integrated circuits have become bigger and bigger, and they now have millions and millions of those devices into a very compact circuits. So it's an evolvement of those microcontrollers itself. So at the heart of any PLC or any DCS system is the same microcontroller which is there, which takes care of the operation. Only thing, the things have become very efficient, and the capacities have increased so much that the speeds of the devices have increased so much that earlier it used to be probably in the second, then it came to milliseconds and in microsecond. Now today we are talking about micro and nanoseconds like that.
Okay, so what it means is that in some system, traditional automation system, you're still going to be seeing microcontrollers, and maybe in some recent systems that are the new systems, you're going to be seeing more PLCs and DCS. Am I right?
Yeah.
Okay. Thank you.
It is the involvement of the same system. The only thing that we are keeping, the efficiencies keep on improving, the sizes keep on reducing, and we have got very compact and very rugged system. And with the circuit boards and all, earlier they used to have a single side, now you have got multiple sides both, and then you have got SMTs like surface mount devices and all those technologies. So they have made these systems very rugged, very compact. So nowadays, even if you look at the laptops and the palm tops and all, they are all having the same devices and very, very compact, and you can take them anywhere. They are not prone to failures due to vibrations or temperatures. Look at the cell phone. If you just compare your earlier cell phone with today's smartphone, you can just imagine the kind of evolvement that has taken place. It also has got so many controllers and all, very compact and very, very reliable, very, very energy efficient. So cell phone is one of the best examples that you see the evolvement of the electronics, how it has evolved. The initial ones were only for making phone calls, then we have got cameras, music systems, everything is now built into the smartphone. It's a small computer basically.
Yes, thank you. Thank you.
Yeah. So now we have a look at the process industry, introduction to the process industry, overview of continuous and batch processes, and role of automation in process industry. And then we'll discuss about the types of automation in industry. We'll look into the process industry, type of process in this industry. Now, process is defined as a series of actions or steps taken in order to achieve a particular end. What exactly is a process? Any process is basically the series of actions which are taken in order to achieve a particular end. Like we just simply talk about machine shop. What exactly is going You're taking the raw material in the form of a rod, let's say, and you're putting it on a turning center, and then it is programmed to perform certain operations, turning, boring, maybe casing, threading, mold. At the end of it, you get a shaft, threaded shaft with hole or internal or external threads, maybe slots. So that is a simple process. So similarly, the process can be very complex also. So as we understand, this processes are defined as a series of actions or steps taken in order to achieve a particular end. The process, as used in terms of process control and process industry, refers to the methods of changing and refining raw materials to create end products. So, as I said, that you take a raw material and then you perform certain actions and steps to achieve the final product, whatever you want to make. So, the raw materials which either pass through or remain in a liquid, gaseous, slurry, or mix of solid and liquid state during the process are transferred, measured, mixed, heated, or cooled, filtered, stored, or handled in some other way to produce the end product. So, we are talking about a process like, let's say, steel industry. You have the raw material in the form of dust, iron ore, lump. So these are then made to pass through a sequence of processes in controlled environment. So changes from solid to liquid, it is molten, and then this transfer, measured, mixed with various other chemicals and fluxes, and then finally it is formed into shapes like what we see in the end product, maybe the black product or maybe rods, bars, structures, etc. So that is a simple explanation for the process. Similarly, it could be for chemical or petrochemicals where the raw, the crude oil is made to pass through the process of purification, distillation, and we get various products from petrochemical products from it. The process industries are those industries where the raw material is subjected to physical or chemical changes which transforms or converts it to different products or products. Like you said, like the petrochemical industry, the crude is after all these processes finally converted to lubricants, diesel, turbine, efficient turbine fuel, or gasoline, or like that, or tar. The process industries include the chemical industry, the oil and gas industry, food and beverage industry, pharmaceutical, water treatment, and power industry. Even in the power industry, see that what happens is we take basically it is water which is converted to steam, and that the power of that steam is used to drive the turbine to finally generate power. So that is also an industry where you convert water into steam and then the power, and then again when the steam is condensed and recycled back to work again. The process in these industries can be done in batches or as continuous process. Now, these operations can be performed in two ways. One is that you have a continuous process where from one end you feed the raw material and passes through the different processes, different steps, and finally at the end you get the finished good. That's a continuous process where you continuously keep on feeding the raw material and the finished product or the end product keeps on coming out at the end. But there are other industries where these operations are done in batches, like you have a certain amount of raw material which are fed into the system, and after the completion of the process, you get certain amount of finished products, and again you repeat the same process. So this keeps on going from batch to batch. So we call these are batches. It's a limited quantity which is processed at one time. We will be having a look at the some continuous and batch process example. Batch process is the manufacturing process where the final product required is produced stage by stage at different workstations. So it is not one continuous flow process. You have different stages, different batches are processed. So you from one step, you take one batch, starts from one end. So after completion of one stage, those products will be transferred to the next, and then the next operation would be performed, and then that batch would be taken to the next station like that. So in batch process, identical products are produced by means of assembly lines. Automobile industry is a good example of this. The raw material used to create these products are same from first product to the next product. And pharmaceutical is also a good example. Food and beverages, paint industry. So these are the examples which we have batches, which in the continuous process is the manufactured process in which from the receipt of raw material to processing of final product happens continuously. There is no break in between. Like you don't have to collect the finished product from one step and transfer it to the next and then to the next. So that is the main difference in batch and continuous process. In continuous process, the raw material is either bulky or fluid in large quantity that flow continuously and undergoes chemical reactions or is subjected to heat treatment. These are the 24/7 kind of industries which have specific maintenance periods. So in a continuous process, the raw material normally in the continuous process, the quantity handled is huge. Like it's a bulk manufacturing process where the raw material is fed from one end and continuously processed through different steps. So it is either bulky or fluid in large quantity that flow continuously and undergoes a chemical reaction or subjected to heat treatment. Like I told you, the steel industry is one of the best examples for this. That the iron ore is fed from one side and it goes through the process and then you get the finished product from the other side. So, but for these kind of industries, as you know, any machine, it cannot work continuously. It has to have its own maintenance is required, especially if the working conditions are very, very harsh. You have to have good maintenance practices. So these industries require shutdown periods in between. So they run continuously for maybe a month, 2 months, maybe a couple of months, and then they have to be stopped for maybe a couple of days to take care of the maintenance requirements, and then again will be working. Whereas in the batch process, you get time in between for the maintenance of this machine, so you don't require a long planned shutdown effect, and in between you can maintain this machine. But in the continuous process, you don't get a chance to stop the machine in between and do the maintenance. So examples are like refineries, chemical plants, or as I said, the steel plant, blast furnaces. So these are continuous processes where the process runs continuously for days or months together, and you don't stop in between. And then we finally stop for planned maintenance for a couple of days or maybe weeks, and then after refurbishing or repairing the machine, we finally start again and run for long periods of time. In food processing industry, which makes sauce, the process from receipt of ingredients to making the sauce happens continuously, and this is a continuous process. So the filling of sauce into bottles of different sizes happens in a batch process. That the bottle of a specific size and predefined number will be filled at a time. Once this batch is completed, the next size bottle is taken for filling. So now this is a combination of continuous and batch. You can say that at one end we are feeding the raw material in the form of tomatoes and it's getting processed, and that goes on continuously, and then the product is stored in silos or hoppers, and then at the bottling end you have a batch kind of thing where different sizes of bottles are different work come in different batches. So it's a combination of the two. It's just an example. You can see that it's a continuous come batch process, I would say. Then comparing the batch and continuous processes, there are various factors when we are going into the process. Uh, like the cost of factory and equipment in the continuous process is very high because we have to install equipment which can handle that volume, number one, which can handle a large amount of raw materials, and which can work in the rugged environment because you are going to do a lot of uh, uh, chemical, physical processing, high temperatures and all involved. And they also have to be extremely reliable to keep on working for long periods, maybe weeks and months together. So whereas the cost of equipment is very high as in the continuous industry, then the batch is low as compared to the continuous. Then the rate of production, again, in a continuous process it is high because we are installing the equipment which can handle huge amount of raw material, and the processes will be efficient only when you are handling large volumes uh, because it will not be economical to run that process at low volumes. So the volumes have to be high, then only you'll be able to get the economical advantage. So rate of production is high, and the batch, case of batch, it is low as compared to the continuous process. Shutdown times. Uh, in the continuous process, I said it keeps on running for long periods of time, and you have planned shutdown after long periods of time. But in the batch process, once you get time in between the sequence, so it can be shut down. Shutdown times are often. Now, workforce requirement, it varies actually from process to process, but uh, for a very high level automated uh, plant, the continuous process would be needing less people as compared to the batch process, because batch then uh, if you compare in terms of ratio, it will be more in terms of for the batch industry. Ease of automation for the continuous process, it is relatively easy because it's a continuous process. You know the process flow, so you once the transfer of material is internally, you are not breaking the sequence and all, so it is relatively easy. In the batch, it is slightly difficult. If you look at the automation for the automobile industry, you will find that it's extremely complex. Whereas in the continuous industry, you are basically concerned with the monitoring of the process variables only. So that way, it is easier as compared to the batch. Now we'll have a look at the process of a thermal power plant. Like you know that a thermal power plant, what it's doing is it is generating power by through the thermal route, that is the uh, giving the heat input to the raw material water and heating it, generating steam, superheated steam, and then with the power of that steam, it is driving the turbine, which in turn a turbine driving a generator to generate the power. So if we look at the input side, the left bottom corner, you see the inputs are basically coal is the fuel supplier. Like the coal provides the energy for this. We are talking about a thermal power plant. Now the coal, water are the main ingredients which we feed into the. So the coal is fed to the boiler, and coal is burned in the boiler basically. It requires air for the combustion. So this coal is burned in the boiler to generate heat, and we supply water through the tubes, which get evaporated in the tube. It's heated and converts into steam. And then the steam, you see there are various circuits of steam. So the main scope for control here is like combustion control in the boiler. So there you need a lot of instrumentation for controlling the combustion. So you'll have the, as you can see, you have air flow control, coal flow control, then pressure inside the boiler, and then a very critical control in the thermal power plant is the drum level control. You can see on the left corner is a boiler drum. It is the water which is sent to the for heating is through the drum only, and the drum level is a very critical control in the thermal power station. So the drum level has to be maintained always, because if you run dry, the level is too low, then the tube may get damaged because there is not sufficient water. If it's too high, then again there's a problem. That's because it is inside the drum there's an interface of water and steam. The top, the red portion will normally be steam, and the green portion at the bottom is the water. So the water goes down from the drum to the evaporator, and then transforms into steam, goes back again, then comes back for superheating, like that, and the superheated steam is then sent to the high pressure turbine here, and to the turbine again after the steam is spent, like its energy is taken by the turbine, it again comes back and then goes to the intermediate pressure, again transferring the balance energy into this, and then finally the low pressure turbine, finally it is condensed and comes back for recycling. So it is again comes back and goes back in circuit. So it is recovered and again used again. And you can have a look at some of the parameters, like what kind of pressures and temperatures you can encounter in the thermal power plant. So you can see the temperatures here in the boiler at 1300 degrees centigrade, where the coal is burning. Then the drum, you can see the pressure is at the order of 168 kg per centimeter square. Temperatures in the range of 320 degrees centigrade. Then here the main steam is 1 kg centimeter square, and at temperatures of 540 degrees centigrade, which is superheated steam. Then in the reheated steam, the pressures are 35 kg and the temperature again 540 degrees. And it is a 3-cylinder turbine basically. We can see 1, 2, 3, a 3-stage turbine, and the capacity is 210 megawatts. And when you come down, you see that here the temperatures have dropped to 244 degrees centigrade and the pressure is still 180 kg. So these are the parameters which are being monitored and controlled in a thermal power plant. So this is just to give you an idea about the process variables in industry and what are those. and how these processes are working. Then you can see the flue gases are being generated here in the boiler. So these flue gases would again have certain gases which will be analyzed and then controlled. It will give you an idea about how the combustion is going on. Like mainly CO, CO2, oxygen is monitored in the flue gases. That will give you an idea of how the combustion is going on. And when you finally have a cooling tower, where this cooling, the steam is again cooled down to condense it and recycle it. So that is an example of thermal power. And I would also like to have a look at some of the processes in the steel industry. I'll just show you integrated steel plant process. Steel plant normally can you hear me? Hello. Hello, audience. Can you hear me? Hello.
Yeah, I can hear you.
Yeah, just give me feedback. I mean, any queries you can ask. Between, just give you an overview of the processes, and that will give an idea that what kind of parameters you will encounter in a process, and you can also imagine the kind of automation that is required. We'll be discussing later on, so that we'll keep on correlating to these processes later on. So just give you an understanding of the processes. Now, this particular slide, if you can see, it gives you an overview of an integrated steel plant, how steel is made. So you can see on the left-hand side, we have the raw material portion. So iron ore is the main raw material. We also use coal, limestone in the process. So here you can see that the iron ore is, there are two routes which can be followed. One is through the sponge iron or the direct reduction iron here. The other is the blast furnace. So this iron ore is fed into the furnace, and from the furnace we get the either the direct reduced iron or the pig iron here in case of blast furnace. So this is then again taken for refining into the steel melting shop, where we have got arc furnace, or it could be basic oxygen furnace, where it is refined to make steel. And then we have another little furnace where it's further refined and then taken for casting, and it is casted into required shapes, and finally passed through the mills to roll it into the flat products, the HR coils, as it is called, hot rolled coils. So this is one example. Then here again, if you see that the raw material which is being fed is at the ambient temperature, maybe 30-40 degrees, and then when it is passed through these processes, the temperatures go up to 16, 17, 100 degrees centigrade. And here again in the steel melting shop, it is in the molten condition. So it is maybe at around 1800 degrees centigrade or so. And then finally it is cast here. The temperatures again would be in the range of 12-1300 degrees centigrade. So then coming down further from the earlier slide, the steel which is cast is again sent further for processing. So it could be in the rolling mills, could be in the form of plates, and be further used to make pipes, or it could be the flat rolled, hot rolled sheets. The strip mill is converted to strips, and these strips are further converted into the cold mill for cold rolled coils and sheets, which are used for white goods like refrigerators or washing machines or the car body. And similarly, it can be further processed through rolling mills into tubes, structurals, or bars and rods. So that is another stage. Now here again, the automation would be deployed to control all these processes like rolling mills. They've got huge drives, there is speed controls, there are geometry control of these sheets and all will be required, and the temperature controls, etc. will be the automation part. Then we'll have a look at the blast furnace. Normally, what happens in the blast furnace basically is you have the raw materials in the form of iron ore, flux, coke, sinter, and pellets. This is fed from the top to the blast furnace, and on the bottom we are supplying hot air, hot blast as it is called, maybe 1150 degrees centigrade, and that generates the heat, and finally combustion takes place inside this, and we get gases from the top, and the raw material keeps on coming down through this furnace, and gases would be rising up, and the reaction takes place, and finally you get molten metal at the bottom, and the gas is escaping from the top, the dust is removed, covers are there, and then finally the energy from these gases is used to run the turbines for power generation, and we take out the finished product in the form of molten metal on the bottom, and then this is taken for further processing. Here to generate the hot air, we've got huge blowers at the bottom, and this blower, this air would be passing through the stoves to heat this to maybe 1150 degrees, so that hot air is doing all the work here, and you can also see some coal and all is injected into the furnace for generating heat. So that is blast furnace. Then another example is the lime calcining plant, where you are calcining the lime for using in industry. So lime is mainly used in the steel industry for as a flux for refining. So here again you can see that it's a limestone which comes from the mines, is fed at one end from the top here, and then it is screened for a particular size, and it is then fed through these skip, as it is called, from the top, and it would be going into the furnace. So there are two shafts going into these furnaces, and it is calcining takes place inside these, and you get finished lime at the bottom. So as you see, we converting calcium carbonate into calcium oxide in this particular process. So again, here the temperatures would be in the range of 12 to 1300 degrees centigrade in the furnace, and a lot of material handling is involved in this. As you can see, it is 500 ton capacity hopper, and the spill capacity itself is 275 tons per day. It is producing 275 tons of limestone every day, or lime in fact, from limestone every day. And then finally you get the finished product at the bottom, which is taken from here and then stored in these bins. Again, that is screened and taken through these dumpers to the users. So that is another example. Another example is air separation unit. Have you ever thought how you get the? You've seen mainly you might have seen in the hospitals and all, there are oxygen cylinders, and even in when some people are welding and all, they are using oxygen cylinders. Have you ever thought that how that oxygen is produced? Can anybody tell? Can anybody tell any idea how that oxygen is produced?
No, sir, I don't have an idea.
Okay, see, the air which we are breathing is having around 21% of oxygen, and balance around 78% is nitrogen, and some other gases are there. So that oxygen basically is produced from that air only. So here I'm showing you a block diagram of the process, how that oxygen is generated. So what they are doing is basically they are taking the air from the atmosphere and compressing it, then they're purifying it, and finally that after purification it is cooled in the heat exchanger, and it is cooled right down to 170 minus 180 degrees centigrade. So once it goes to that temperature, it liquefies. That air turns into liquid, and then there the distillation takes place. So we distill the different products of that air, because now it is in the liquid form. So oxygen is the heaviest component. It settles at the bottom. Then you have nitrogen, like that. So that oxygen is taken out from the bottom. So here you can see in the process, the gaseous products we are getting is gaseous nitrogen and gaseous oxygen, and the liquid products what we are getting is liquid oxygen and liquid argon after distillation. So that oxygen which you see in the cylinders and all is produced from the ambient air only. We also get nitrogen and, and argon. Those are the other components which are available in the air. So this process also required a lot of automation and instrumentation at every stage, right from air compression, purification, heat exchange. So at all these steps you need the automation. So this is just to give an idea that what different processes are, and then we'll be having a look at the when we go for automation. Then you can have an idea that how the automation is taking place in all these processes. So any queries up to now? You have any queries on this? Have you sent me the your email names and emails so that we know who all are there in the today's session?
Excuse me, I have a question, please.
Yeah.
In all these processes that we just had an overview of, is it possible for one person to have actually an understanding of the automation of all these processes for different systems, as in the ES separation unit, limestone manufacturing, and the rest of them? Such that probably you can move from one industry to the other. And is this something that you have been able to do over the years to be able to achieve this, or is it something that you encourage people like us that are that want to become automation expert like you to just focus on one industry and master the process?
See, we have given you an overview of these industries just to generate that query, like you have said, that how we are controlling these complex processes, and because as a general this thing, if you don't go into the details, you will not appreciate the kind of automation involved or the kind of complexities involved in these processes. So the basic idea of giving an overview of these industries was to generate this query that how they are controlling this, or what are the process variables and all. Because the next, when we go for the instrumentation part and then to the PLC part, then will be then you can easily correlate with exactly how the application of these equipments is involved in these industries. Otherwise, if I plainly tell you that this is a pressure transmitter and it measures pressure, or it's a temperature transmitter which is measuring the temperature, or it is a PLC which is controlling logic, then it will be an open loop kind of thing. So once you have this background in the mind that I am going to control a particular industry or a particular process, and these are the process variables, those are involved, then you'll be able to appreciate the use of that equipment in a better way. When I tell you that this is a pressure transmitter, then you can easily correlate that, okay, I've seen the thermal power plant and there was the pressures of the order of 150 kg per centimeter square. So definitely this is the kind of equipment that I'm going to use there. And then you'll be able to appreciate the real use of that. Or maybe a PLC, when I tell you that it is used in the lime calcining plant or a air separation unit. This is a sequence. So then you'll be able to appreciate it better and then correlate better that use of that equipment in the process industry. So that was the idea, to give you an overview of the industry. I hope you understand the thing.
Yeah, it's clear. Thank you.
Yeah. And we'll also be having some assignments in between. I'll give you some assignments based on the presentations that we are giving you. So that will be, I mean, that will increase your involvement into these sessions. Otherwise, it will become more of a one-sided affair. So next time on, we'll give you an assignment on these processes, so that after the session is complete, you can go through those assignments and do it, so that it will be kind of revision, and then it will increase your involvement also into the training process. So we are preparing some assignments for you, and keep on giving those assignments to you. And that is why I just want your email IDs and your names, so that we know who are all there. Assignments can be sent to you, and then you can work on those assignments and send it back to us. But, you can just have a look and see what kind of involvement you've gone through the training sessions.
Okay, sounds good. Thank you.
So, any other queries for today's session? If you want, we can just have a look once again at the process part. If you just want to have another look, we can just have a look, and then we can close today's session. See, a typical blast furnace like this would involve thousands of instruments at every stage, because there are so many parameters involved. There are so many different sections of the process, and you have to have each section monitored and controlled to have uh, an efficient process, and control the quality of the product which is coming out at the end of the process. Because you must realize that at the end of the process, if you get a bad product, you don't have any means to control it or any means to rectify it. So it has to be done right the first time. That is the most critical part. That it has to be done right. Otherwise, it will be a waste at the end of the day. So uh, throughout the process, at every step, it has to be controlled. It has to be monitored and controlled properly to get the desired end result. And a typical blast furnace would be having thousands of instruments. And if you look at the automation part, I would say that a huge automation system is required to control this kind of furnace, which will be having thousands of inputs and outputs to be measuring various process parameters, monitoring various sensors, and based on the feedback, it will be giving commands to again thousands of manual control elements like valves or uh, maybe the feeding systems and all to correct the process and bring it to the desired level. Similarly, for a line producing plant, we'll be having again hundreds of instruments at every step to control each step, to control each sequence. It has to be it has to be weighed, it has to be measured, and the quantity is to be added. Then it has to be in a particular ratio. It has to be in a particular condition with the temperature. Then only you'll be able to process it right and get the final product. Similarly, in air separation unit, it has to be at the desired pressure, desired flow, desired temperature. Then only you'll get pure product at the end of the day. The oxygen which we are generating here is purity level is 99.99%, like that. But, that oxygen has got various uses, like right from the medical field, will be given to the patients and all, to the process where again we require purity levels, very high purity levels. So if you don't control it, then you won't get the desired result. If you don't measure it, you won't be able to control it. So you have to see it in that way, that it has whatever you want to control, it has to be measured accurately. Then only able to control it accurately. So with this, can we close the today's session? Any queries? I can answer that. So our next session would be introduction to process control systems, and then we go to the field instrument part, and then we'll go to the PLC. So I hope you are having this particular thing, the curriculum with you. You can also go to the website and MindSnap website and get information. You can just have a look at the curriculum or some of the knowledge base which is stored there for your own curiosity. If you want to see, a lot of information is available on the website. You can just have a look at that, and then I think the next session is Tuesday. Right? So we'll be meeting again, and then in between, if you send me the mail IDs, I'll be able to send you some of the assignments. You can go through the assignments, and then when we come down next time, then we can discuss it.
Do you want to send us our individual email ID, or Peter is going to kind of collect them?
Yeah, you send me your name and individual mail ID, and then you can send the assignment to you. And we'll also have a look at who all are attending today. Right? So please send me the mail ID.
Do you want it now, or you want us to get your email?
You can send me the chat box right away. So that,
oh, okay.
Yeah.
Sir, I have sent my email to you.
I'll send my email too.
Yeah, I did.